And this is the electricity homework booklet question 17 and 18. In the circuit shown, V is a voltmeter with a very high resistance. The internal resistance of the cell R is equal to the external resistance of the circuit. Which of the following is not equal to the EMF of the cell? That's an important spot. So the reading on the voltmeter when the switch S is open. So when the switch S is open, there is no current. So the terminal PD, which is what that voltmeter is reading, is the EMF minus the PD across the internal resistance. Well, if there is no current, which there can't be if the switch is open, then that term disappears and that voltmeter will read the EMF for you. So that is true, therefore it's not my answer. The chemical energy changing to electrical energy when a unit charge passes through the cell, definition almost of EMF, that is true, therefore not my answer. Twice the reading on the voltmeter when the switch is closed. The EMF, so when the switch is closed, I've got a PD there and a PD there, both equal to I little r. So that EMF is divided equally between those two resistances, and so that one is also true. And D, the electrical energy produced when unit current passes through the cell. The electrical energy produced, that should be per unit charge, not per unit current. Therefore D is wrong. D is the answer. Fill that in now. There we go. D's filled in. Remember, on these multiple choice questions you're filling in the blob. And moving on to question 18, I've got three identical cells, each of internal resistance R connected in series with an external resistance R. The current in the external resistor is I. If one of the cells is reversed, what's the new current in the external resistor? So I've drawn these out. So I've got my three cells all pointing the same direction, each with their internal resistor and the external resistor. I did a little sum, I actually worked out what the current was. It's 3/4 of the EMF upon R. I've drawn it out again with two cells pointing in one direction but one pointing in the other direction. That means that the total EMF now will be epsilon plus epsilon minus epsilon. We've got a minus epsilon EMF there. So if I do V equals IR this time, I've only got epsilon, not 3 epsilon. That's going to be I times 4R. And so the current is going to be epsilon upon 4R, which is a third of the current it was in the original. Perhaps easier to think of it simply this way. In this case, the total EMF is 3 units. In this case, the total EMF is only 1 unit. If I've only got a third of the EMF with the same total resistance in the circuit, I'm going to end up with a third of the current. So the answer is going to be 18. And so that is very badly coloured in. You'll do a better job in the exam. And that is the end of question 18 and the end of the AS homework booklets.